Hey, welcome back to the series. In the first episode, we have seen how to install Node.js through NVM, and in this episode, we are going to see the introduction of the PEAN stack, and also what we are going to see or implement in this series. So this stack consists of four key items. First one is PostgreSQL, which we use as a database, and then Express.js, which is a Node.js web framework, and Angular to build UI interfaces, and Node.js server-side runtime environment. So the PEAN stack is an acronym that stands for PostgreSQL, Express.js, Angular, and Node.js. So first, let's talk about PostgreSQL. So this is very powerful and it's open source relational database management system, and it is known for its reliability, data integrity, and support for advanced data types. And also, when it comes to Express.js, this is a very minimal and flexible Node.js web application framework, and Angular is very popular, and it's a very full-blown front-end framework. And Node.js is a server-side runtime environment where you can run this whole application on the server. So this is one of the popular stacks, and we will see how we can implement this while development. So first we need to run PostgreSQL as a database on your local machine or any cloud environment that actually runs on port 5432, and we have Node.js API that runs on port 5000. And also when it comes to Angular, so when you use Angular CLI, and it runs the Angular application on port 4200 by default, you can change the port as well. And even in Node.js API, you can change the port. I just put an example 5000 here, but you can change the port as well. So that way, every service runs on their own port. That way, it is faster and easier for you to develop, especially when at the beginning stage of the development. So let's look at the development environment, how we can develop end-to-end flows, especially when you are on our local machine. So basically, you run PostgreSQL on your local machine on port 5432, and you run the Node.js API, you set up Node.js API and run on port 5000. For example, it's for 5000, but you can change the port. But this Node.js API will connect to the database, and you can have all CRUD operations: create, delete, read, and modify. All these operations you can do through HTTP network. So that's basically we are building Node.js REST API, which serves all this data from the database on port 5000. So we are going to build the UI with Angular, and this Angular code is running on port 4200. So whenever there is a data needed to fetch from the database, the Angular will call the API, Node.js API, that is running on port 5000, and the Node.js API in turn talks to the database, and it fetches the data and it serves that particular data through HTTP call. But there is a mechanism in Angular framework where you cannot directly call this Node.js API because these are running on different ports, and you will get coarse error. So to avoid that coarse error, there is a mechanism where you have to maintain a proxy config.json in which you need to define whenever there is an API call, you have to call this Node.js API that is running on port 5000. For example, you can define /API. Whenever there is a /API in the URL, it forwards all that HTTP requests coming from the browser to the Node.js API. So basically, you hit, for example, you hit the data. You hit localhost 4200 on the browser, and it loads the page from the Angular application. But the page needs to get the data from the database. So at the time, it will make the service call, and this service call will contain /API in the path. So that whenever there is a /API in the path, we have a configuration in proxy config.json it will forward all those requests, HTTP requests, to localhost 5000 where the Node.js API is running. So that is how the communication happens, especially in the development environment. So that way, um, you can develop the whole web, the, the full stack web application much faster and easier. And also all these, while development, you can configure to watch files so that you don't have to restart again and again. Let's look at Docker Compose, how to use Docker Compose while development. So anyway, first of all, we need to understand why we need Docker Compose while development. For example, so you have you have a new mission, and you need to install each and everything. You need to install Node.js, you need to install PostgreSQL, and you need to install Angular CLI. So you have to install everything. So, and also set up the mission. So even though if you do all these, there is no guarantee that it works. So so that's why when you have Docker installed, when you have a Docker Compose file, all you need to hit Docker Compose up command to run all these services together, so that you can actually run the whole end-to-end application on your local machine. And also this is really important when you debug, or whenever you get into a new project and wants to debug the whole end-to-end flow without setting it up everything on your local machine. These kind of development environment on Docker Compose will be really useful. So let's look at the individual services in the Docker Compose file. So let's look at the UI. So it doesn't matter whether Vue.js, Angular, or React. So the UI service looks similar. So we are building, the first command is build. Either you can pull the Docker image from some container registry, or you can build the Docker image by providing Docker file. So here we are providing Docker file, and in the Docker file there are a number of steps and to generate a Docker image. So basically when you run Docker Compose up, it will read the steps from Docker file and it will generate the Docker image. And there is a port section where you can map internal port to our external port, and you can name the container. When you run this Docker image, there is a container, and so you can name the container. So we are basically naming the container men UI here, but it doesn't matter. But we are talking about PEAN, you can just put PEAN UI there. So networks. So Docker networks is the bridge where all the services will be running on, so that they can be communicated with each other. And the volumes, so the containers, you can easily destroy the containers, and these containers are ephemeral. So that means you can easily destroy the container. When you destroy the container, all the data inside the container will be lost. So to persist that particular data and also decouple the data from the container, we actually have volumes. So for now, for the data persistence, we use volumes. So there is a completely separate episode on the volumes. We will look at it later, but for now, we use volumes for data persistence and also the sharing data between containers. And we can mention, we are mentioning it depends on the API. That means for this service to work, it is actually depending on the API. So it will, so before this service, before this container starts, the API container will be up and running. So that is what we are mentioning here. So let's look at another file, another service where we are mentioning the API. It's very similar. We are actually building the Docker image from the Docker file here, and also we have port section, and also we are naming the container, and the network is the same because these services has to be communicated with each other, so that basically we are running on the same network. And we have volumes for this API as well, and also basically depends on the DB. So without DB, you cannot actually serve all the data through RESTful API. So that's why it depends on the DB. And let's look at the DB file where you can actually see. So you can notice there is a distinction here where we are pulling the image here. So we are not building the Docker image from the Docker file. We are pulling the image from Docker Hub. So the image name is Postgres 14. So, and also we are defining environment variables, and the ports 5432, 5432, we are mapping internal port to external port, and the volumes, we have volumes here. And yeah, so there is a complete different section to explain all these in detail, but don't worry about it for now. But all we need to do is, all we need to know, there is a Docker Compose file. When you run the command Docker Compose up, it will create all these services and run all these services as a containers, and so that you can run your full stack web application on your local machine. So as you can see in this picture, so the whole application is running on your machine without installing any other stuff. Basically, all you need to install Docker, and you need to have a Docker Compose file. When you hit Docker Compose up command, it will create all these services. All these services are running on these ports 5432, 3080, and 4200, and you are hitting the application on 4200 or 3000, whatever the port that is, the UI is running on. So all you need to hit that port, and you can test or run the whole application without installing Angular or Node.js, any all the dependencies. So that is the advantage of using Docker Compose as a development environment. But let's get into how we can build this application and run in production. So when it comes to building this, first we need to build Angular or whatever the front end UI, React or Vue.js, whatever that is. First you need to build, and you need to put all the static assets in the public folder of Node.js API. So then you have to use either any bundler. So the famous bundler is Webpack. So you can use Webpack, and you use Webpack to build the Node.js API, and this Node.js API will have this public folder, and whenever you hit, so basically you bundle the whole Node.js application with these public assets, and you actually run this bundle on any Node.js runtime environment. So you can run this on Docker, or you can run this on any Node.js runtime environment. So when the request comes from the browser, so the browser hits Node.js API on port 5000, for example here, and so whenever it needs to load any UI, it actually takes all those assets from the public folder, and it sends those public assets to the browser. So that way you can build and deploy the whole web app, whole full stack web application in production. So one way to deploy the application is zip it and deploy this whole zip into any Node.js runtime environment. And another way is to Dockerize. So when you Dockerize the this full stack web application, you need to use multi-stage builds. So what actually this multi-stage build means? So if you look at this file, the Docker file, where we are building the whole application for production, so we are using stage 1 as UI build. So we are building the whole UI application and name that stage as UI build. And look at the stage 2. In the stage 2, we are building the API, and we are naming this build as API build. So we have stage 1 and stage 2, and we have built UI and we have built API. Now we don't need any dependencies. So whenever you look at any Node.js project, we have the dependencies called node modules, and that is huge in number. And also, so when you build the application, you will no longer need those node modules. So that's why in the third stage you are actually taking the built assets from stage 1 and stage 2 and you are copying those into different folders. So all we are doing in the stage 3 is we are copying the built assets from stage 1 and stage 2 and put those into different folders, and we're in the last step we're actually running node API bundle.js. So in the second, when you are building Node.js API, you are using Webpack. So it will generate one bundle.js, which is API bundle.js here. And we already seen all the static assets from the UI will be in the public folder, and you will have this API bundle.js. This API bundle.js will have all the code, all the static assets from the UI, and all the API code. Everything will be present in this API bundle.js. So in the last command, all we are doing is we are just running this API bundle.js. In this way, we can decrease lot of surface area, so that the attacks will be decreased, and also there is a lot of, it's a lot of size reduction as well. Your image will be very smaller. So whenever there is a smaller image, your container will be up within no time, and there will be a lot of, there are so many advantages as well, other advantages, but we will look at those advantages in detail in another episode. But that is the advantage of using multi-stage builds. So far we have covered the main things, but there is a lot more in this series that we are going to create episodes. So we will see how to set up PostgreSQL, building API, and we will see how to configure PostgreSQL in API, and also how to build UI and making API calls from the UI, and the whole complete development environment setup, and the Dockerizing this whole stack, and the linting, and how to unit test, how to integration test, how to build for production. We're going to create separate episode for each of all these points, and don't forget to subscribe. Thank you for watching.